Test, test, test. Good. All right, so let's start exponent laws. There are 4 basic exponent laws. So basic. First is the law of multiplication. Which says that when you're multiplying powers with the same base, you keep the base and add the exponents. So what is a power? A power consists of a base and an exponent. So it has a base and it has an exponent. So the whole thing is the power. So the law of multiplication says that when you're multiplying powers with the same base, you keep the base and add the exponents. Okay. The law of division says that when you're dividing powers with the same base, you keep the base and subtract the exponents. On your test, there's always like a fill-in-the-blank section. So I could say when multiplying powers with the same base, blank, and it has to be fully keep the base and add the exponents, or keep the base and subtract the exponents for law of division. Law of power says when you are raising a power, so this is a power, consists of a base and an exponent, to a higher exponent, you keep the base and multiply the exponents. And the law of zero exponents says that anything to the exponent is 1. So a to the 0 equals 1. One of the most common mistakes that you guys have been making is the fact that you think that if I have a to the 6 divided by a to the 6, okay? So then, which law is this out of the 4? Law of multiplication, law of division, law of powers, or law of zero exponents? Yeah, it's law of division. So when you would keep the base, which is, yeah, and then you would subtract the exponents, which you would get. Right. And so what a lot of you guys have been doing is you've been saying, oh, well, if it's a to the 0, then the answer is a to the 1, which I do not have to write. But no, that's not true. It's a to the 0 should be your first line, and then you should be going equals 1. The whole thing is 1. If you write a without anything there, that means it's a 1. Okay? It means it's a 1. So you have to write a to the 0, then write equals 1. Okay? All right. So let's do a couple examples with this. If I give you 3a squared times 2a to the 4. Now this has coefficients on it. When you have coefficients, they work very differently than the powers. So these are the coefficients, and these are the powers. They work very differently. But they work normally. So if I had given you 3 times 2 on its own, the answer would be 6. Okay. Then you work with the a squared to the a squared, which is going to be a squared times a fourth is going to be a to the what? Yeah, you would add exponents. Okay. Another example. If I give you 5a to the negative 2 times 3a to the 7, this equals what? Mox?
15a.
Yeah. Yeah, good. -2 plus 7. If I give you, let's say, 3x -2y times 2x 2y. What does this equal? Yeah. So 3 times 2. Good. Yeah, very good. So it'd be x to the 0, right? And then if you do not see an exponent, that's implied to be 1, right? So you've got y to the 1 plus y to the, or times y to the 1, which is y to the 2, right? But what is x to the 0? Right. It's 1, right? So then, but then what's going on between the 6 and the, right. So then it's 6y squared. Okay. What if you have 12a to the 17 divided by 4a to the 4? So you work with the coefficients on its own. 12 over 4 is 3, good. And a17 over a4 is? Yeah, very good. So a to the 13. What if you had this? 16 over 12, a to the -2, a to the -5, b, and then c to c3 there. Let's do that. So in this case, you have a 16 and a 12. You treat 16 over 12 the same way you always have. If you have 16 over 12, what do you do? If I had given you 16 over 12 on its own, why is that? Why can't you leave it 16 over 12? Yeah, you have to reduce. So you can reduce this by what? Don't say 2. You can reduce it by, yeah, you can reduce it by 4. So then you divide, don't subtract, right? So 16 divided by 4 is? Yep, good. And 12 over 4, or 12 divided by 4 is? Good. So then this, in the same way that 16 over 12 would reduce to 4 over 3, the beginning part is 4 over 3 here. Okay. Now, you have a to the -2 divided by a to the -5, right? So this is dividing powers with the same base. You have to keep the base and subtract the exponents. At this point, it is not grade 9. You don't get marks for showing integer work, so you could use your calculator. But you do want to be thinking, at least to yourself, that -2 minus -5 means the same as -2 plus 5, which is, when adding integers with different signs, you keep the sign and add the, you take the sign of the larger and subtract. So the sign of the larger is a +5, so it's +3. 5 minus 2 is 3. So you get a to the 3, because -2 minus -5 is 3. The b here does not have anybody to work with, so it stays exactly where it is. Okay. And then for the c's, you've got c to the 3 over c to the 2, so that's going to be c to the 1, which you cannot write 1 here. I take off marks if you write 1. Okay? You should only be writing c. Now, let's talk about when the exponent in the denominator is higher. So if I gave you x squared over x to the 7, but there's a y4 up here and a y here. So again, this is law of division, but you should be subtracting in the direction of the bigger exponent. So you should not be doing 2 minus 7. You want to think to yourself, where is the bigger exponent? Is it on the denominator or is it in the numerator? Who has the bigger exponent? The denominator does, right? So because the denominator has the bigger exponent, then the answer should go in the bottom, and you go 7 minus 2. The answer gets put wherever the larger exponent is. So if I have y4 over y to the 1, then the bigger exponent is clearly on top, so it should be y to the 4 minus 1 is 3. I'll let you do this one on your own. Tell me what the answer to that is. Okay, so for the a's, who's bigger, -6 or -5? Yeah, so the answer should be on the bottom. So then in your calculator, you need to be typing in -5 minus -6, which is the same as -5 plus 6, which is 1. Very good, so a to the 1. Okay. What's bigger, -3 or -10? Isra? Good. So the answer should be on top, because that's where the bigger exponent is. So -3 minus -10 is the same as -3 plus 10. So when adding integers with different signs, take the sign of the larger and subtract. So you get 7. So b to the 7. Then what's larger, 3 or -3? Obviously 3. So you're really typing in 3 minus -3, which is the same as 3 plus 3, which is 6. So the answer should be c to the 6 on top. Okay. All right. That's it for basic exponent laws. Now let's go on to negative exponents. A negative exponent moves the entire power to a different floor. then the exponent becomes positive. Let's do a bunch of examples. All right. So x to the negative 2, the power has a negative exponent. Right now, is it in the numerator or is it in the denominator? Yeah, it's in the numerator. So that means now the entire power is going to move to a different floor. So it's going to move to the bottom. And when it moves to the bottom, the exponent becomes positive. But we cannot leave the numerator blank. This looks very improper mathematically. So what we do is we write 1 on top, because that's the number that's left over. Okay. When we have 3x to the negative 2, okay, again, we have to take care of the negative exponent. So it moves the entire power to a different floor, but the base of that power does not have the 3. The negative 2 is only on the x. So the answer to this is 3 over x squared. The 3 does not move because it didn't have a negative exponent. Okay? If I have this, though, then the base of the power is 3x. It's the entire thing. So that whole thing is going to move to the bottom. So it's 1 over 3x squared. 3x quantity squared. Okay. If we have this, right now the x to the negative 2 is in the bottom. It's in the denominator. So when it moves to a different floor, that's going to move it to the top. Now you don't need a placeholder for the denominator. Even though the denominator is blank, we don't need to write over 1. Okay. So this moves to the top. In this case, the y has a negative exponent and the x has a negative exponent. Because the y and the x both have a negative exponent, this is going to become 5x to the 2, y to the 2. The 5 does not have a negative exponent. It does not move. The x negative 2 does move to the top, and the y negative 2 does move to the bottom. So this is our answer. Okay? But what if our base is a fraction? So if the base is a fraction, the negative exponent will flip the base to become positive. Let's go x over y, negative 3. So when I have x to the negative 3, y to the negative, x over y to the negative 3, the negative 3 is applying to both the x and the y. So to make it positive, it flips the fraction to make it y over x to the 3. To make this one positive, 1/3, it's going to flip the 1/3 to make it 3 to the 2. Then for 5 over 2 to the negative 1, of course, it's just going to flip it, and we don't need to write 1. Okay? All right. Now we start getting hard. Law of products. When an exponent is on the outside of a product, for example, 2x squared y cubed to the 4, the exponent applies to each factor. So 2x squared y cubed to the 4. When the 4 is on the outside like that, it applies to each factor. So it applies to the 2. It applies to the x squared. And it applies to the y cubed. The most popular mistake that's made here is thinking that 2 to the 4 is 8. It is not. 2 to the 4 means 2 times 2 times 2 times 2, or you type it into your calculator, and you get 16. X squared to the 4th, that's law of multiplication, so we'll get x to the 8. Y cubed to the 4, that's law of multiplication, we'll get y to the 12. Okay. We're going to hear, I already drink as loud as it is, and now on here, it's going to be incredibly loud. The law of quotients. For the law of quotients, when an exponent is on the outside of a quotient, the exponent applies to each factor again. So it goes 2x over 3y squared to the 2 equals 2 squared, x squared, 3 squared, y squared squared. It applies to each guy, so you get 4 x squared, 9 y to the 4. tough examples. Start off a little easy. From this, we know that when you have, from BEDMAS, we know that we should take care of exponents before multiplication. So you should definitely be applying these exponents on here before you try to multiply these two. So the 27 should not be times the 2. As well, the 3 is not on the outside of the 27, so the 3 does not go to the 27. Also from BEDMAS, we know that when we have an expression written over an expression, you should be working out the entire answer for the top and the entire answer for the bottom, and then you can divide between the two. Okay. So if we apply the exponents first on this, do not say 6. This is 9a squared b squared, because 3 squared is 9. On here, do not say 6. It should be 27 times 8 a6 b negative 3. The 3 applies to the 2, the 3 applies to the a squared, and the 3 applies to the b to the negative 1. Okay. Now we can multiply. Sorry, this should be working down here. We can multiply the bottom before working with the numerator and denominator. So our numerator does not change, meaning we should recopy it. Okay. And then we do 8 times 27, which is 216. Okay. Now we can apply law of division for this. If we had 9 over 216, you can type that into your calculator, right? You can use the fraction button to help you reduce it. That's going to reduce. They both divide by 9. So 9 divided by 9 is, of course, 1. And 216 divided by 9 is 24. So we get 24 down here. I'm not going to write the 1 here yet, just because I don't know whether the top is going to be blank or not. Between a squared and a6, who is the bigger exponent? a6, so that means the answer should be on the bottom. And we get 6 minus 2 is 4. So we get 24a4 on the bottom. Okay. Then we have b squared over b negative 3. So who's the bigger exponent? The top is? Yeah, exactly. So then we get b to the 2 minus negative 3 is the same as 2 plus 3. Yeah, very good. Okay. So then that's the answer there. Let's get even harder. What if I've given you 7a squared b negative 1 over 14, let's not do 14. Yeah, let's do 14. 14a cubed b squared 2. Now we're combining law of products and quotients, and we're combining it with negative exponents. Here's the thing to remember. Okay? When you have negative exponents on the outside of quantities, always take care of that first. Always take care of its movement. So this -1 applies to this, everybody on the inside. Because it has a negative exponent, it should be not flipping, because it is not a fraction. It should be moving to the bottom. So the next expression should read 7 over 14 a cubed b squared squared a squared b. It has a negative exponent, so it should be moving to a different floor. But none of these other guys had negative exponents, so they shouldn't be moving at all. And so I just straight up recopied them. I'm not going to be working with them yet. I just work with the fact that this has a negative exponent, so this entire expression moves to the denominator. Okay? Now we can work out the entire bottom. So 7 over 14. We'll take care of exponents before multiplication. So we apply the 2 on both the a3 and the b2. So we get a 6th, b 4th, bracket a squared b. I'm going to keep the bracket there to indicate that I'm multiplying. Now I can multiply out the denominator, and I get 14. Law of multiplication says that I'll add. So I get a8 and b5. I cannot leave my answer like this because now I can reduce between the 7 and 14. So I get 1 over 2a8 b5. Okay. Okay, so here, again, you can work with the inside on this, but I generally always say that if you have a negative exponent that's on the outside of a bracket, if you have a negative exponent on the outside of a bracket, you should always take care of the negative first. So the negative exponent here is on a fraction. It is different from this, which was not on a fraction. The base of the exponent was not a fraction, but this exponent is applying to a fraction. So in general, I say, take care of that first. What do I mean take care of it? Is make it positive. So what it'll do is it'll flip this fraction. So now this is 9x 5 y negative 8 and 3x squared y cubed. Okay. That did not make this y negative 8 positive. Yes, we moved the floor on it. We moved it to the numerator, but that was because of the negative 2. So that does not change this. Okay? So I take care of the negative exponent because it's on the outside. That doesn't mean that, and that's why I don't take care of the y to the negative 8. I'm not going to move this to the bottom before I do anything because it's not on the outside. When it's on the outside, that's when you take care of it. This is on the outside of a bracket. You always take care of that first. Because what I'll do in here is now that I have positive exponents, I'll follow BEDMAS. BEDMAS says work within brackets first. So working within brackets, I have a 9 over 3, right? So if I have a 9 over 3, then I have 3. I have an x5 over x2. Where is the bigger exponent? Holy shit. It's on the top. So it's going to be x to the 3. Because 5 minus 2 is 3. It's only for our kids, so I can swear. Yeah. Yeah. It's like no one else is going to see this. And even then, I don't fucking care. So here, we have a y to the negative 8 over y cubed. Okay? For this, the bigger exponent is on the bottom. You always got to ask yourself for law of division, where's the bigger exponent? The bigger exponent is on the bottom, so the answer is going to be y. 3 minus negative 8 is the same as 3 plus 8, so you get y to the 11. But I have not touched the squared, so I have to recopy it. Now, for those who are watching this video or here who have already learned this in class, then it's not, like I'm the only one who really explains, who really encourages you to subtract in the direction of the bigger exponent. It just prevents mistakes. So like if you, most teachers teach y to the negative 8 over y to the 3. You subtract exponents. So you get y to the negative 11, and then you have to move it afterwards, right? But I don't want you doing that because I want you to just have positive exponents. You don't have to worry about movements. Because if you had a y to the negative 11, when you're in the middle of a test, sometimes you think to yourself, when you move things improperly. If I had a y to the negative 11 up here, maybe you would have moved the whole thing. You just end up making more mistakes that way. This combines both steps at one if you just practice that. Let's finish off. So we apply the 2. This is law of quotients. The 2 applies to each factor. Do not say 6. 3 squared is 9. X to the 6, y to the 22. That's your final answer. Okay. Last thing is rational exponents. So we have 4 basic laws: law of multiplication, law of division, law of powers, and law of zero exponents. We have 2 intermediate laws, so medium difficulty, which is law of power, law of products, and law of quotients. Advanced is law of negative exponents. Really advanced is law of rational exponents. So the law of rational exponents, this is the one new thing to grade 11, because that was all supposed to be review. So law of rational exponents. Rational means that your number or your exponent is a fraction. Okay? So it'll look like something like x to the m over n. So your exponent is a fraction. If I had an example of that, it would be like x to the 3 over 4. Okay. This is called rational exponent form. You can change it to root form because when you have a rational exponent, it really means that it is a root. The numerator here, this is the exponent. This n is called the root index. So that's the number on the outside of the root. So this would be the nth root of x to the m, or the nth root of x to the m. Both are okay. Okay, these ones, normally we use this one, but sometimes this is given. So the thing that you want to remember in your head is that the bottom number is the root, the top number is the exponent. So if I have this, the fourth root of x cubed is the answer. Because the top number is the exponent and the bottom number is the root. That would be like this on this form. Both are the same. It's just saying that this one, it's kind of like the cube is in tighter on the x, like you're cubing it first and then you're fourth rooting it. Here, you're fourth rooting first and then you're cubing, which is technically usually what we do. Okay? So let's change forms. All right, if you had x to the, let's say, 3 over 2. What if you had 2x to the 7 over 5? What if you had 3x to the 10 over 9? What if you had 7x to the, let's go, negative 1 over 4? And what if you had the square root of x? Actually, let's change this. Let's make this fifth root of x squared. And then that. Change those forms. Like a stool. What? Yeah, it's fine. I don't need. Change them? Yeah, you should try it. Okay. God bless me. That's on camera. All right, let's go. So this is in rational exponent form. So it's this, this, and this. But these are in root form. So we're going to change these into rational exponent form. So we're going to change this into a root. So it's going to be the square root of x to the 3. Okay. But there's something you should know. We don't need to write square root. When the 2 is on the outside, we don't need to write it. So this is really the square root of x cubed. When you don't see a root index is the number on the outside of a root, you don't need to show it. It's a 2 if you don't see it. Here, all right? The 7 over 5 does not apply to the 2. So this is 2 times the fifth root of x to the 7. because the 7 over 5 is not on the 2. Here, the 10 over 9 is on the 3, is on the coefficient. So this is going to be, 3x is going to be underneath. Okay? You've got to keep a bracket on that, because when you leave the exponent of 10 on there, if you don't put the bracket, then that 10 is going to look like it's only on the x. And then you've got a 9th root on the outside. Okay? This, you've got a negative exponent on the outside. You have to take care of that first. So I need to move this to the bottom, which becomes a positive 1/4 now. Anytime that you have a negative exponent on the outside, you take care of that first. Then you can change it into root form. You're going to have 1 over the 4th root, the bottom number is the root index, of 7x. In this case, I do not need a bracket around the 7x because it's an exponent of 1. We do not need to show an exponent of 1, just like we don't have to show a root index of 2. This, the 5th root of x squared. Okay? That will be, we need to change that into rational exponent form. The exponent is the numerator. The root index is the denominator. Okay? Here, it looks like there is nothing here or nothing here. What's the exponent then? Yeah? What's the root index, if you don't see it? Yeah, good. So you get x to the 1 over 2. Okay, there's one last one that's really tough that a lot of you guys have missed. Or one more type, I should say. And that's something like this. 6t cubed, like this. Or something like 3a squared b cubed to the 4. When you have a more complicated expression underneath the root, like this, okay? When you have a more complicated expression, you need to put brackets around this for yourself. That way you can think about this as having an exponent 1 on the outside. By putting that bracket there, now you know that you're going to change this into root form, into rational exponent form with 6t cubed as your base. But way too often, if you don't put a bracket there, you think that this 3 is, this is the most common mistake. This is what you guys do. You obviously know that this is a 2. You guys go 6t to the 3 over 2. Well, when you write it like this, you're saying that the over 2 doesn't apply to the 6, right? You need to put brackets around it and change it to be like this, so that the root index of 2 applies to both the 6 and to the t cubed. That's the same thing here. You have a 1 on the outside now, so then it's bracket 3a squared b cubed, that's your base. That's going to be to the exponent 1 over 4. Cool. So why do we have to work with these? Because now, what about when you get this? this is a big 3. How do you simplify that? When you have letters, it is better to work with this in rational exponent form. So you need to change them to not have roots. This is very similar to what I told you to do over here. You need to put brackets around these so that you can change them. This becomes 3, and your base is x squared y, with an exponent of 1 on the outside and a root index of 2. This has a base of 27x5 y to the negative 1, with a exponent of 1 and a root index of 3. To simplify this, I hate working across, but I'm going to. Now, just like the ones we were doing before, you have to work out the entire top, work out the entire bottom. The 1/2 will go to both of these. The 1/3 will go to each of these. So, 3, what do you do with exponents when you apply the 1/2 to the x squared? If this was 7, what would this become? It'd be 3x to the what? If that 1/2 was 7, it'd be x to the what? Yes. If I gave you x squared y to the 7, you would more easily tell me x to the 14, y to the 7, because you would multiply the exponents, right? Just because it's a 1/2 doesn't mean you do anything differently. You multiply the exponents. So on your calculator, 2 times 1/2, well, if you have 2 halves, you have a whole. So it's x to the 1. Then you have y to the 1/2 times 1, so y to the 1/2, like that, okay? If I gave you 27 x to the 5, y to the negative 1 to the 2, what would you have done? You would have applied the square to the 27, applied the square to the x5, applied the square to the y to the negative 1. Well, that's not going to be any different. So you would have thought of what's 27 squared. You would have typed that into your calculator. Well, if it's 1/3 instead, you just type in what's 27 to the 1/3. Well, 27 to the 1/3 is the same as the cube root of 27. What cube makes 27? 3. But you could have just typed that into your calculator. 27 to the 1/3 is 3. 5 times 1/3, just like you would have done 5 times 2. That would have made 10. Well, that's going to make x to the 5/3. Then you have y to the negative 1 to the 1/3. You multiply the exponents, you get y to the negative 1/3. Then use law of division. 3/3 reduces. It's gone. X to the 1 over x to the 5/3. Who is the bigger exponent? 5/3 is like 1.67. It's 3/3 is 1, right? So 5/3 is bigger than 1. So the answer is going to be in the bottom. On your calculator, you would do 5/3 minus 1, which is the same as 5/3 minus 3/3, because you'd need a common denominator for fractions. So you get 5 to the 2 over 3. Okay. Who's bigger? 1/2 or -1/3? Yeah, so on your calculator, you're going to type 1/2 minus -1/3, which is the same as 1/2 plus 1/3, which if you found a common denominator of 6, it'd be 3 over 6 plus 2 over 6. So you get y to the 5 over 6, because the numerator, y to the 1/2, is the bigger exponent. That's where the answer goes. That's your answer. Last one in exponent laws in module 1 is this. Okay. Again, you have a complicated expression underneath a root. You've got to put brackets around it. But that expression is underneath another root. So you've got to put brackets around that. I'm going to put square brackets there. Okay? We can take it in steps, though. So maybe I'll take these off so that you can see clearly what I'm going to do. I'm going to leave the cube root and think about what this expression is. Okay? If I think about what this expression is, what's the exponent on the outside? So we know that the base is 64, x 12, y 18. What's the exponent on the outside here? Yeah, it's 1. So that's the numerator. What's the root index on this one? What's that root index? Yeah, it's 2. Okay? From there, I have an expression underneath a root. So what I can do is I can cap it in brackets. You get 64, x to the 12, y to the 18, to the 1/2, with square brackets around it. What's the exponent on the outside of that square bracket? What is this exponent? Yeah, 1. What's the root index? So you get that. How do you answer this? Law of power says when you're raising a power to an even higher exponent, you keep the base. And what do you do with the exponents, 1/2 and 1/3? Multiply. When you multiply fractions, you go top to top, bottom to bottom. So we get 1/6. Law of product says when I have an exponent on the outside of a product, it applies to each factor. So that's like saying 64 to the 1/6. We don't multiply 64 and 1/6. We type in for coefficients into our calculator. We type coefficients into our calculator. So 64 to the 1/6 is the same as 6 root of 64. So what do you get when you type that in your calculator? Yeah, you get 2. But we do multiply exponents. So 12 times 1/6 is x to the 2. 12 times 1/6, remember, top to top, bottom to bottom. And finally, y to the 3. That's the answer. And that's it. Pause that. Stop it.